ChatGPT a question. Okay. You say, AI bro, how much did we make last year? And if you ask a normal ChatGPT that question, it will have no idea what you're talking about. But you build this chatbot so that it can query from your company's database. So the ChatGPT will ask your company's database for that information. It will come back, and then the AI will use it to make an answer. Your company made $5.50. Ooh, not good. So how does this work? We're going to talk about something called embedding, which is basically just taking a word or a sentence or even an image and putting it somewhere in space, giving it some coordinates. So let's say we put the word cat over here. This is a three-dimensional space right here. We've got the Z, got the X, we got the Y. Okay, so we put cat right there. Then maybe computer is way over here, and they're far away because the concept of computer and cat, they're not related. So they're far away in space. And then maybe rice is down here because that's really far away too. But dog is pretty close to cat because they're both house pets. So they're pretty close together in space. Then military, is way up over here because it's not related to any of these concepts. And then maybe beans is pretty close to rice because they're often mentioned in the same sentence. So then what we do is we give coordinates to each of these words. So for example, cat, if we look on here, we go up to here, we go down here. And then so on the x-axis, cat is 1.5. And then we see on the y-axis, okay, cat is probably around 5. And then on the z-axis, it looks like cat is around maybe 50. So that's our coordinate system. We locate words in space. So this is 3D space, but vector space has a lot more dimensions. Vector space has hundreds and even sometimes thousands of dimensions. So if we are trying to visualize vector space with thousands of dimensions, we cannot. Humans cannot do this. We cannot visualize this because we've only ever experienced, 3 or 4 dimensions, right? Fourth dimension is time. So, this is all we've ever experienced. So we cannot visualize vector in thousands of dimensions, but computers are really, really good at that. So that's what we do. It's called embedding, where instead of doing, finding cat's location in 3 dimensions, we do it in hundreds or thousands of dimensions. Why would we do this? The reason why is because you can find similar concepts even if you don't know what keyword you're looking for. So for example, in a traditional keyword search, you have to know exactly what the word is. Like if you are searching for computer, but you use a different word, if you use like electronics, the word computer will not show up because it's a different word. Or if you're searching for beans in a traditional search, rice will not show up because even though it's a related term, it's not the exact same term. Keyword searches search for the exact words. Vector searches are kind of a little bit more fuzzy. They search for concepts. So let's say that you query something. In a normal database, a keyword database, if you said, I'm looking for an animal, all it would return to you is the word animal, and that's it. But this is a vector database. So we align things by their meaning, right? Similar terms have similar meanings. So if we enter a query into our vector database, I'm looking for an animal, then we vectorize this, we embed this, create coordinates for this sentence. Those coordinates might be right there. So we're looking for an animal, and then the coordinates for that sentence, when we turn it into a vector, are right there. And then that helps us because then we can look at the closest concepts to that query, which would be cat and dog. So I'm looking for an animal, and then we see, oh, these concepts are very close. So these are the closest queries. These are really good matches for that query. Whereas if it was over here, rice and beans are not a good match for animal, neither is computer, neither is military. Now we're going to talk about chunking. So why would you want to divide documents up into chunks? So let's say you have a really long document. Let's say you have the Constitution, and you want to get some information out of it. Why would you want to divide that Constitution up into chunks instead of feeding the whole thing to AI? And the reason is ChatGPT can only understand around 32,000 words before it starts to forget things. And this is kind of a complicated explanation. It goes along with the architecture, but it's just basically a limitation that we have to work with for now. So you cannot put in like the whole Constitution because it's much longer and you won't get a good response out of it. It won't understand the whole thing. Also, reading things and writing things from ChatGPT can get very expensive. So if you're using the API, it costs 3 cents for every 1,000 tokens. Token is like part of a word, and it costs 6 cents for every 1,000 tokens that you generate. So reading costs 3 cents, generating costs 6 cents. So it can get very expensive, especially if you have this huge long document. That's a lot of money just to read one, especially if you're doing this all day with a lot of different customers. So the rule of thumb is you got to have a balance. You got to make the chunks small enough that you're saving money, but big enough to contain useful information. So it depends on your situation, but 600 to 1200 characters is a pretty good rule of thumb because they're long enough to be containing good information, but they're short enough to be short enough that ChatGPT can understand the full text snippet. So, but like I said, it really depends on the situation. So, for example, we were talking about your company's income. So this would be really bad chunking right here because it's too short. Our department has an annual income of, and then chunk two, $40 million, which is phenomenal. So this would be really bad because if you are doing vector search, like we said before, this chunk would show up. This chunk would be queried, or you would query, our company's income, and this chunk would show up, but this chunk would not. This is kind of the tag. It's what the information has that will be queried. And then this is the actual information that you wanted. And so it would be a lot better to have those in the same chunk because then they would both be returned and your AI would be happy. Whereas if this gets returned, your AI will still have no idea how to answer the question. So this is better chunking. A whole idea is in one chunk. Enough meaningful information for the AI is in one chunk. Our department has an annual income of $40 million, which is phenomenal. So if you searched for annual income, you would get this, the annual income, and you would get the answer. Okay, so there are many tools available to help with chunking, including LangChain. LangChain is designed specifically for retrieval augmented generation, and also NLTK, Natural Language Toolkit. So here's a little bit of an overview of how this works for changing your text into vectors. We all know that OpenAI makes ChatGPT, but they also have an API that you can send anything to, and it will send you back a vector. It's called ADA002. So you just send your text to that API and you get a vector back. And it doesn't have to be text. It can be like images or kind of any data you want, and it embeds them in vector space. And the texts or the ideas that are similar to each other will be close in space. And then there's a particular thing called a vector database, which is designed to store vectors and search between them. One of them is called Pinecone. It's free to use. It's not the best vector database. I don't recommend it, but it's really easy to set up and it's free. So it's a good way to learn. They delete all your data after 1 week, just to know. Okay, so we can look at the Pinecone code in a little bit, but here's an example of how the prompting works. So we said, okay, here's the question. The user would enter this into your chatbot. How much did our company make last year? But your chatbot doesn't really know the answer to that. So what you would do is you would run it through your own program and you would say, please use the chat history, if there was any chat history, and the user's question to create a query for a vector database that will return information to answer the user's question. So you're using ChatGPT to generate a query. You don't have to do this, but I find it to be very effective. So you take this question, you tell ChatGPT, hey, please give me a query for a vector database relating to this question. ChatGPT sends the query back, and it looks like maybe 2022 income statement, right? So that's the query that you're going to use on your vector database. So you send this to your vector database, and then your vector database comes back and says, okay, this was the closest thing we found. We made $4 million, and it'll give you the name of the document. If you put that in your vector database, you put vector, text, and the name of the document. So you get this back, and this is the answer. So then you tell ChatGPT, you say, okay, here's our question. Here's our information to answer it. Now I would like you to put these two together, and I would like you to give me an answer. like a well-formed, beautiful looking answer that doesn't have all this extra information. I want it to look pretty. I want it to look like a conversation because that's what people like. And I also want you to tell me what your sources were. And then so ChatGPT will come up with this cool phrase and it will say, last year in 2022, your company made $4 million. So that's just the combination of the question and the information and this prompt that you sent saying, please make a nice answer to this question.